Hey everyone, my name is George. This is CS61B Fall 2020, question number 3 from midterm 1. It's called DMSEquals. Let's get started. The first part of this question says, suppose we define the following strange class. Note that the equals method has the signature equals student other. Recall from lecture 11 that the objects classes equals method has the signature equals object other. That is, this class is not overriding the equals method. And this is because they have two different signatures. Their parameters take in different static types. So looking at student, we have string name and SID. So these are the two properties of the student, as well as our equals method that compares if their names are the same and SIDs are the same. Next, we have 5 objects that we create, 5 job objects that are shown. And so to help us with the next bit of our question, which is kind of like, what do these things print out? We're going to draw some box and pointer diagrams to really demonstrate this. So I know some TAs use the box, but or the table to denote static and dynamic type, but I think I prefer drawing like the box and pointer diagrams and working from there. So first, let me just hide names. But now, so first we have SB. So we look and we have SB. So we can draw like SB. We know that this is a student variable. And this points to a student object, the name Borf in the SID 1, 2, 3. Next we have SG. So SG is also a student object. SG points to a student object that has the name Gorf 1, 2, 3. Next, we have a student called SB2 that points to a student Borf 1, 2, 3. And then finally, we have 2 objects, which are kind of unique. We have object OG, and this points to the same object as SG. As you can see in this line, points to the same object as SG. Next, we have object OB2, and this points to the same one as OB2. So from this, we can tell all the static types, which are listed here on the left, and the dynamic types, which are the things that they point to on the right. So now let's get started. So we have SB dot equals SG. So static type is student, and this has static type student. So we go into the dot equals, or we go into student class, look for dot equals student. We find that here with the one provided. So we take note of this equals student. This is the method we were looking for. Now, SB is dynamic type student. So therefore, we need to also go to the student class. And of course, we found this in the student class, so it's going to exist in the student class. And from that, we can use this equals method. This equals method checks the name and the SID. From our chart, we know that SB has name Borf, SG has name Gorf. Those are different, so this is going to return as false. Next one, similar process. They're both static type student. So we go student class, look for equals student, find it here. In runtime, we go to student class again, because this is a student. We also find it here, the same one. So we compare them again. This time, SB and SB2 do have the same name and the same SID, which means this returns us true. All right, next we have equals equals. This is a little interesting. Equals equals basically checks if the 2 objects are the same object. Not necessarily that they have the same values, but they are the exact same object. And that's where the box and pointer diagram comes in handy. Here we see that SB points to this student, whereas SB2 points to that student. These 2 are different student objects. So even though they have the same value, they are 2 different student objects, and equals equals will return us false. Next, we have SG not equals OG. So this is where things get a little tricky. SG, static type student, OG, static type object. which means now that we go to our student class, we look for equals object. We can't find it here, which means it doesn't exist. So we go up to the parent of student, which is object. And here we're told that it does exist in the object class. It has equals object. That is what we're looking for, and we find it. Now in runtime, we know that this is a student. We go again, student class. But again, earlier, like we didn't find it there, we also can't find it here. Equals object does not exist here. That's why we have to go up to the parent equals object and use this one to evaluate our expression. So sg.equals og, the objects.equals method essentially works the same as equals equals. It'll return true if they are the same object, return false otherwise. So we look here, SG points to this student object, OG also points to this student object. So since they both point to the same student object, this is true. All right, next, SG equals OG. Like I said earlier, the object equals method with another object is essentially the same as equals equals. They check if they're the same object. We see here, again, they are the same object. This points, SG points to this, OG points to the same one. So this is also true. All right, next we have SG.equals student OG. Well, this is static type student. This is also static type student. So this runs very similarly to what we see up here, except this is SG instead of SB, but they're basically both students in static type. So just like this one and just like this one, right? So how that works now is compile time, static type, student, student. We go to the student class, we look for equals, we find a student. So equals student. So we save this address. During runtime, we see that SG is a student, student object, which means we go to the student class, we still find object student, so we run and execute this method. SG.equals student OG, well, they both have Gorf and they're both 1, 2, 3. A plus also that you can notice is that they both point to the same object, which means that they're bound to have the same values. So this is true. All right, next we have SB.equals OB2. SB here, static type student. This one, static type object, which means we are looking in the student class for equals object. Here in the student class, we can't find it. Like we did earlier, we have to go up to the objects class, the parent of the student class, to find it, and we find it here. So we keep track of this signature. Now during runtime, we see that this is a student. We go to the student class. Again, we can't find this, so we go up to the objects class, the parent of the student, and we use this equals object other. Again, this is checking if they're the same object or not. We have SB.equals OB2. Well, SB points to this student, OB2 points to this student. They are different students, which means this will return as false. Just like we did earlier, dot equals with object as a parameter serves just the same as equals equals. So because this is false, we can also say that this is false for the same reason. SB and OB2 do not point to the same object. All right, for the next one, SB.equals student OB2, static type student dot equals student static type. So we go to the student class, look for equals student. Student class equals student, we find it, we're good to go. SB is actually dynamic type student. So again, student class, we find it, good to go. This is the one we look for. Dot equals OB2. Well, SB has borf 1, 2, 3. OB2 has borf 1, 2, 3. So this will return us true. All right. Now the last one's a little bit tricky, but this is how we go about it. This has a static type object. This has a static type student. So we go to the object class looking for dot equals student. Well, the object class only has dot equals object, but we're in luck. Students are objects. So this equals object works. And this is the method signature we remember, equals object. So now during runtime, we see that SB2 is actually a student. So we go to the student class and we look for what we found. In compile time, we found equals object, and that is exactly the one we look for. But in the student class, we don't have equals object. So that means we have to resort back up to the object class and use the object class's equals object method. So that, again, just checks out the same object. We know that SB2 points to this student, OB2 points to this student, and this will return us true. All right, now for the next part, suppose we fix the equals method so that it takes an object as an argument instead of a student. Once we've done that, we are now properly overriding the equals method. So we have a overridden thing here. Essentially, we just take it as an object, cast it to a student, and run the same checks as above. Finally, for this question, we have what returns true now that did not return true before. So if we look up here, we only really care about the ones that returned false because the ones that return true already returned true. One thing to note is this false and this false both use equals equals, right? If we make a change to dot equals, that doesn't change equals equals. So these two can be ignored in terms of doing part B. So basically, we're only looking at this one and this one. So first, this one, if we change it to equals object O, we have SB dot equals SG, static type student. This is also static type student. During compile time, we go into our student class and look for the equals method. Well, this is the only equals method in our student class because we overwrote or we rewrote the other one. We're in luck because students are objects, so this one checks out for this. So this is the one we use. During runtime, SB is a student. We go back here, we use this same equals, this is the same one we found, and we actually compare them. But we'll notice that SB has name Borf, SG has name Gorf. So no matter what, this is still going to return us false. So that's not the one we're looking for. Now if we look for this one, now let's try rerunning this one. So we have static type student and static type object here. So we have student class looking for equals object. This is the equals in the student class and it has object right here. So this is the method that we saved, the one in the student class. Now a dynamic check, which is runtime, we have SB, which is a student. We look for equals object and we find equals object in the student class. That's this new one that we wrote. And we check if their values are the same, double checking. We're looking at this one. SB has ORF 1, 2, 3. OB2 has ORF 1, 2, 3. Therefore, we know that they have the same values, and this will return true given the new function that we have here instead of false as it did before. So there we can check this one, SB dot equals OB2. Okay, now finally, we are looking for the equals method. Does not follow all the things that we said that an equals method should do in lecture. Describe at least one improvement we can make below. We were basically looking for three things. If you mention any of these three things, you got credit for this problem. The first is null check. Here we are casting O to a student, as well as trying to obtain values from other. Those will run into problems if we have null values passed in as O. Another thing we can do is we can make sure that this O is actually a student, right? We cast it to a student here, telling Java that it is a student. If it's not a student, we'll run into problems because if it's not a student, there's no guarantee that it'll have a name attribute as well as an SID attribute, and that will run into problems. And the final thing that you could have mentioned is that if this, so the student calling equals, is equals to the object O, this essentially just means that they are the same object. If they are the same object, you can return true. Because they are the same object, they have the same values, they point to the same thing. And those are the three main things that we were looking for part C. But yeah, that was overall question 3. Hope this was helpful.